distracted there. Oops. 1 minute late. Hello, hello. Should be some math in front of you if you are curious what to do while I wait to get notified of my live stream. There we go. April Fool's, got him. Oh, that's a good April Fool's, because you love math. Kids Bop Dance Break is live right now. Wow. Kids Bop. That's the dream. I also can't believe you're missing it, Sajana. I got Quattro Preguntas for those of you who are here to begin trying out. I'm trying to increase the variety. Wow, we're 3 sophomores so far. Sophomore power. Like, not actually sarcastic with that. Like, good job, sophomores. And hello, Kelly. And hello, Aspen. Now we got all the classes represented. Ain't no freshmen in this class. Hello, Daikun. And it's Nick. Nick, who actually did his homework, too. So that's pretty sweet. You didn't do very well. Bummer. I tried to pick out questions that I think will be fairly indicative of what's going to be on the AP tests. Because I think they're going to have calculator questions that are going to be hard to type into like Wolfram Alpha or any sort of like equation solver. And so those sort of analyzing questions usually are better for that. Can you go over those awful FRQs today? Yeah, sure. Feels bad they were awful. Although I guess feels good because if you struggled on them, it means we have some places where we can learn. So that's cool. Hello, Keith. Hello, Tim. You think you failed them all? Remember, failing is getting like a 3 out of 9, so like a 33% and below. So failing is a different cutoff than normal when it comes to AP free response questions. Because if you got like 4 out of 9 or above, that's actually like a passing score. Are these questions calc active? The questions here are not calc active. No, none of these require a calculator. AP website went down for me. Sorry, dude. It's probably getting slammed with a lot of people, is my guess. So if you go at non-peak hours, you're probably going to be more successful. Is Mr. Kennedy talking? Yes, I am. Is your computer muted, Liam? I know they don't require one, but I want to use one. Uh, don't show weakness. Uh, Can you show us how to actually show our work on the computer? Yeah. I was planning on doing that. I wish I could switch back and forth between my desktop computer and my uh, Surface, so I could do my Desmos on there while looking at the questions, because I'm kind of between a rock and a hard place when it comes to doing this, because I can't be logged in more than one place at a time and all that sort of garbage. So I'll try to figure that out. Yeah, I can do snipping tool of Desmos, but I almost feel like I want to just do everything in Desmos, like show the whole process, show like step by step what I'm gonna do. And creating like a 50-page Word document of every single snip of Desmos feels like a pretty boomerish thing to do. So, uh, probably uh, not that. I use Notepad, Desmos, and snipping tool. Alright. Seems legit. I assume they're going to have built-in Desmos, because when I've gone to AP conventions before, they've talked about how they want to integrate Desmos into their like actual AP tests, and so their online version probably will have built-in Desmos. So learning how to use Desmos is probably a skill for this exam. Although I should attend one of those streams to see if that's actually the case. When is that? April 3rd? That's Friday? To figure out what's actually going on here. I'm waiting for Daikun to come in and correct me here. Oh, you tried the lockdown browser. Oh. Which one of these would you want calculator for? None of them, I don't think. 2 is maybe the most likely one? The first one? Huh. Pretty sure I could do that one in my head. AP Trevor says it's going to be all open book. Yeah. Definitely. uh, are you kidding? Like, how could they prevent you from using your book? Like, they can't have cameras. They can't have on a different computer. What like they have to make it open book, open calculator, open all that crap because there is no way to limit you. And yeah, they're absolutely going to be more skill based. That's definitely a no brainer. Definitely questions where it's like they give you the equation ahead of time and you just have to like analyze it. So like our first free response, the only one that I have actually gone through and done beforehand. Uh, so yeah, as per normal, let me know when you finish these. I assume nobody's done or very few people are done as of yet. But yeah. They will send spy flies into our home. That's pretty post-apocalyptic there. Yikes. that scared me the most of any of the like genocide things in college. When we studied that in class, like the sending AI robots, like little tiny AI robots to go kill everybody and that sort of thing. Yeah, yikes. Because it seems very realistic. All it takes is somebody with the means and the bad nature. Are there 2 points that work for number 1? I never actually finished doing it. Think so. Yeah. Wait, no. Because one of them's not on the interval, I think. uh, so that's. If Black Mirror becomes real, I'm going to leave. Some of the episodes are like fairly realistic. A lot of them are a little bit like modern day China, and that's scary. So is it calcul here? These are not calculator allowed questions. None of these require a calculator. So I'm going to go with a no for these. Um, we are going to be starting off these with like no calc sort of questions, mostly because analysis is really important also for this AP test. So while it is an open calculator test, you're only probably going to use your calculator on 30 to 40% of the questions. So, yeah. Yeah, and a stream full of juniors and seniors asking if anybody was in a sophomore teacher's live stream. Interesting choice. Guess we have at least 5 sophomores. And yeah, Zoom should all but be banned right now. Just waiting for me to get banned now. Zoom is banned because it has video features, and video features are not cool for this. I think mine will be okay long term because there are no video features here. And that's a decided advantage. It literally is me projecting a computer screen. And in calculus, we can't get shut down because we're reviewing entirely. Covering new material can be a little shaky at times, but reviewing stuff is totally legit. Just like in real school, teachers aren't allowed to see their students. Now, you forgot something there. We're not allowed to see our students as people. We're allowed to see them, just not, believe in their abilities. Yeah, Raquel, but remembering to do that and liability and blah 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 means it's getting kiboshed pretty hard. Nobody's done with this yet. That's interesting. Oh, oh, we're up to 4 dones on the last one. Seems good. We'll hang out till about the 15-minute mark, which is pretty soon. Then I'll start mobbing these. All right, and I've hit my timer. Let's see if I can be smart about this. And boom, and boom. All right. Oh, look, there's more questions coming before I go over homework. All right. Find the absolute maximum value. You should have done bottom d top minus top d bottom over the bottom squared. If you do that, you should get 6x squared minus 12x minus 3x squared over 3x minus 6 squared. The top you get 3x squared minus 12x. The bottom doesn't matter because its 0 is at 2 and that's not on our interval. So I'm just going to ignore the bottom and look at the top from now on. And if you factor out a 3x, you get x minus 4. Which means the 3 points for testing are 3, 4, and 6 in the original function. Our critical point, that was on the interval. 0 is not on the interval. And then 3 and 6, the endpoints. If we test 3, we get 9 over 3, which is 3. If we plug 4 in, we get 16 over 6, which is 16 over 6. And if we plug in 6, we get 36 over 12, which is 3, which means 3 is our absolute maximum value. So this is why Daikun said, do I get it twice? Did the max happen twice? And it does happen twice, but there's only one max. All right. Question 1 down. Question 2. Find the x value of the inflection points if the derivative equals this, which means I saved you the hassle of having to take 2 derivatives. So if we take one derivative, we do have to do a product rule here. So 10 times e to the 3 minus x squared plus 10x times e to the 3 minus x squared times negative 2x for the chain rule of 3 minus x squared. We can factor out a 10 e to the 3 minus x. And if we do so, we get 1 minus 20x, or whoops, no, 1 minus 2x squared, because the 10 was factored out. And all we have to do is solve this equation for where x, like for where it equals 0. So where 1 equals 2x squared, where 1/2 equals x squared. So x is root 1/2 and negative root 1/2. Which is why you did not need a calculator. YouTube just BSODed your laptop. That means you have an issue in your memory most likely, because YouTube uses a lot of memory. That feels bad. I had bad RAM, which is why I'm working on 8 right now instead of 16, and why my computer bogs down when I'm playing video games sometimes. Feels bad. All right. The question 2 down. Those were our answers. Those were the, I guess these are pips. I should have tested to see if it changes on either side here. So if I test 0 in the second derivative here, I get positive, because this is always positive, and 1 minus 0 is also positive. If I plug in like 2, I get negative. If I plug in negative 2, I get negative. If you're wondering how I got those so quickly, all that really matters is the last parenthesis. And so anything I plug in that's bigger than root 1/2 is going to make this last parenthesis negative, and will make the whole problem negative. And so it does change at both of those, making both of these inflection points. So remember, you just do like a first derivative test in the second derivative to do inflection points. All right. Next one, how to integrate this garbage. Well, it actually works out really similarly. We just have to do u sub. U equals 3 minus x squared. Du equals negative 2x dx. Which means we have negative 5 du's here. If I multiply both sides by negative 5 here, I would actually get negative 5 du equals 10x dx, which is exactly what I want. Cool. So if we rewrite this integral, we get negative 5 e to the u du, which integrates to e to the u because e is awesome. And we get negative 5 e to the 3 minus x squared plus c. So that was not too shabby. And our last question, our last pregunta. This question here required you to do some logarithmic differentiation. So if you natural log both sides, you get something like this. Because the whole reason we natural log both sides is so if we natural log both sides, we get to pull down the power in front. And so I actually get natural log of the natural log of x with the x cubed pulled out in front. Now I'd have to do some product rule. I get on this side y prime over y. On the right side, I get 3x squared times natural log of the natural log of x. And then x cubed times the derivative of this is 1 over natural log of x times the derivative of the inside, which is 1 over x. And now all we have to do to finish is multiply y to the other side, so we get that y prime dy dx equals, what was my original thing? Natural log of x to the x cubed, and times this crap above, natural log of x, and plus x squared over ln x. And it looks like a mess, but it was not too bad to do. All right, I blitzed through these, but I don't see any complaints besides Nick's B-sod. Where is the y? This is the y. Right there, that's y. I just multiplied it to the other side in this last step. And it's my original question because y equals natural log of x to the x cubed. All right. Dos más. Doink, doink. Try these questions out. These use a different skill set a little bit. So we had a little bit of a derivative-y focus in the first half. Now, for a little bit more of an integral focus, let's see if you remember how to do these types of questions. The second question here, you can do in your head pretty easily if you recognize what's going on there. Just a little hinteroonie. Question 1 would be a little brutal to do in your head. A lot brutal. Dang, my numbers are down. Did I forget to put this on my calendar? I probably did. That's sad. I did. Oops, sorry. So yeah, when you are finished with these, go ahead and slap a done in the chat, and I will bounce through these. And if you're struggling with that first one, maybe check what Daikun wrote and see if you remember that. Can you believe we still have more than a month until the AP test? This feels good. Like we've already covered everything. We only only 80% of the material is going to be on the AP test this year. So we have less to even review. Like, things are looking up on this end at least. I'm hoping a lot of people do really well because we have so much time to review. Although, only maybe 50 of my students are getting involved actually practicing. So, rip many people. Maybe only 20 people are doing the assignments I'm assigning, which also rip. Alright, the duns are starting to pile in. Let's do it. Alright, in that first one, I'm just going to do it with synthetic because that's faster if you remember it. And if we do this, doink, 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 doink. Ooh. You can tell I didn't copy this one from a worksheet. Those are some janky numbers. We get that if we divide this, we get x squared minus 4x plus 13 minus 50 over x plus 4. And then you just integrate this homie, and you get x cubed over 3 minus 2x squared plus 13x minus 50 natural log of x plus 4 plus c. I like these questions because they are very rote skill based. There is almost no thinking involved as long as you remember the steps. It's just do division, integrate, use a natural log for that last term. Done. Hooray. Alright. The second one had kind of two different routes. You could do it with u sub, or you could do it by rewriting this as gosh darn it, as secant x tangent x, which is sine over cosine times 1 over cosine, which is sine over cosine squared. Because if you do this, you just get secant x plus c. But you can also do it with u sub. So you can also make u equal the cosine of x, du equals negative sine x dx. You can get a negative du over u squared, like mya. You can integrate this. This is u to the negative 2 du. And get u to the negative 1 over negative 1 times the negative plus c. And you get cosine of x to the negative 1 plus c, which is exactly secant x plus c. So, dope. Either way, same answer. And Lord, my wife's cat is going ham right now. You could perhaps hear it in the background, but oh man. Thank goodness he's in another room. All right, let's go to that homework now, since I don't see any questions piling in here. I should have that open. Right. Yeah. Because I downloaded all these documents that are the scoring guidelines. Haha. All right. In the first one, the big idea was to graph the function given, which was, what? It was some sine of x garbage or something. There we go. 7x minus 19 sine of x squared minus 4x plus 4. And if you look at it on the graph, bam, right here, right there, right there. What was it, from 1 to 4, the interval? Those are our values where this goes through 0. So if I go back to here, those are our answers there. Which is 2.714, and 3.772. So whoops. Which we can get from clicking on the graph. Oh, whoops, 2. There. And those 3 being our values, because that's where the second derivative, where the derivative hits 0, which are our critical points. We could have added extra detail, which is that at 2, 0, we actually have an inflection point, or a saddle point, but not a max or a min. We could have said that 2.714 is a minimum because it switches from decreasing to increasing, which is a minimum. And 3.772 is a maximum because it switches from increasing to decreasing. So just some reading derivative graph stuff. So again, for critical points, all 3 of these are critical points. Only 2.714 and 3.772 are relative maximum or minimum, relative extrema. And the first point, 2, 0, is a saddle point. The first one that happens here is not on our interval. So we would have had to include this 0.228, but it said from 1 to 4. So we don't need to look at that. And how you would justify this, Nick, is we can actually look at how they say it, but basically, here's the idea. You just say, hey, I plugged in the derivative, or I plugged in the f of x that they gave us in the question, and I looked at where it went through 0. Or the f prime of x, the derivative they gave us in the equation. And where it goes through 0, where its value equals 0, is where my critical points are. So look, that's the justification they use. Like, look at their solution. It's literally the derivative equals 0 at x equals 2, x equals 2.714, and x equals 3.772. That's it. All right. Then they analyzed them. Did we have to analyze that for that question? Not really, but all right. Part B. Here's what I did for part B. I figured out f of 1.5, which is my slope at 1.5. Just by plugging 1.5 into that horrible equation. And I got that decimal string there. And then all I did was plug it into point slope form. So y minus y1 equals slope times x minus x1. And x minus x1 was 0.3, y1 was 3. So I just did this equation and got 2.369 for my approximation for that one. You may notice in their answers that they leave things as horrible, unsimplified answer chains. So they're actually cool with either of these. So the first answer up there is the one that I got. Here, let me draw on this. This one is what I got. They're also okay with this. So, like, these don't even require a calculator in reality for the first point. You can just have the work right there. But then you do need to round to 3 decimal places for the final answer, 2.369, to get the second point there. Should we be snipping tool these graphs and place into CB? I mean, probably. As good practice. On the AP test, it'll probably be built in, so you won't have to snip. What should you write out? Literally what I did here is probably good enough. Right there. I tested the value at 1.5, and then I plugged it into the point slope equation. That's probably enough. And then I'd also probably, the one piece I didn't put here is I would actually write out the point slope equation for that question, which was y minus y1 equals slope times x minus x1, like this. I would have this somewhere for partial credit. And the 0.3 is just, they asked for estimate the value at 1.8. So I just plugged in 1.8 for x, and 1.8 minus 1.5 is 0.3. So that's where that came in. All right. Moving on to part C. Oh, Crud Muffino. I forgot what the question was asking. Come on. So I gotta go back. So, they're saying that from 1.5 to 1.8, the slope is less than 0, and the second derivative is greater than 0. So we're concave up, and our slope is negative. So is our answer, is a tangent line an under approximation or an over approximation? So this one straight one we can do on just with a sketch. If we're concave up and decreasing, we look like this. If we do a tangent line, it's an under approximation. Booyah, done. Super hardcore analysis right there. It's that is what is necessary. If you can draw a picture, and all you need to do is draw the right part of concave down or an increasing or whatever, and just draw a tangent line on it, and you can always tell whether or not it's an over or under approximation just from that. And in this case, because we're concave up and decreasing, our tangent line will be an under approximation. So I memorize 0 things for those. I just draw pictures. And our last one says, using the mean value theorem, explain why the average rate of change over the interval 1 to 4 cannot equal 6.5. Okay. So, for this one, what's the most useful place to start? Probably looking at this. How did they give points? Okay, so probably looking at our picture is the most useful place to start. So our interval for this question is from 1 to 4. We're looking at a derivative, and from 1 to 4, I'm going to put some goalposts here. Boom, 1, or whoops, 1 and 4. It says, can the mean value theorem equal 6.5 for this? And it'd be pretty ridiculous if it did, because 6.5 is here, and our graph never even gets up there. So no, the mean value theorem can't give that value. So that's ridiculous. So that, I mean, that's the key idea here is it would have to be on this interval. On this interval, the slope is never that big, so it can't be that. That drawing is too complex. Two lines is too many. Huh? This drawing? I'm confused. Yeah, so that's it. The average rate of change needs to equal the instantaneous rate of change at least 1 point. There's no point that the instantaneous rate of change equals 6.5, so it's impossible for the average rate of change to be 6.5. And that's it. So it's look at the graph, see that it never reaches 6.5 on the interval, and bail. Okay, so people are really expounding a lot. Are people okay with that first question? Okay. No panic anymore. I can end this madness. The graph is now empty. Wait, is the mean value the integral? No, that's the derivative mean value theorem. So it's asking about the rate of change. And so it's asking about the derivative version where the average slope equals the instantaneous slope at 1 point on the interval. Chelsea, you have to cite the mean value theorem because the problem specifically asks you, can the mean value theorem guarantee an average or whatever? So you do in that question have to talk about it because it's in the question that you have to use the mean value theorem. All right, our second one. Let's pull up the question this time. I can never decide where to start because everything looks so different. All right. Okay, so we have this beautiful table here. We also know that, so this is for G. And then f is some completely different function. So we don't actually even use the table for the first one. So we know this initial condition about f, and we also know f's derivative. So for the first part of this question, all we're going to do is take the derivative of f prime. And if we do that, we get cosine e to the x plus x times negative sine of e to the x times e to the x, the derivative of the inside. And then we just plug in sine of 2. Does it have to be shown through the graph? For that previous question, yeah. Yeah, Liam, average slope, going back to the previous question, average slope is just y2 minus y1 over x2 minus x1. And then the graph we had was the derivative graph. And so if our derivative never equals 6.5, y2 minus y1 over x2 minus x1 can also never equal 6.5, which was the entirety of D of the previous question. It was impossible. And so yes, it had to be shown with the graph there. My graph never reaches 6.5, so it's impossible. Is the way you'd answer that. Okay, and this I just type into Desmos and get some garbage. And so I'm going to warp back to the answer. And the garbage, whoops. This looks like the wrong question. Did I open the wrong one? Oh, stinky diaper. Wait. Oh, no, we're chilling. All right. Where's the part where you answer the question? Dear AP. All right. You get negative 2.173 if you plug sine of 2 into that. All right. The second part, part B, and I just realized I can use this now. Cool. Says let h be the function where h is g of f of 2x. Find h prime of 1.5. And if I look back at this, I'm trying to find h prime, so I got to make an equation for that. H prime is g prime of f of 2x times f prime of 2x times 2 for a few different chains there. We're trying to find h of 1 or x is 1.5. So f of 3 is actually something I know, so luckily I'm given this, so I don't have to actually find f by integrating. So really, this is g prime of 2 times f prime of 3 times 2. F prime of 3, all we're going to do is plug 3 into this, so 3 cosine e to the 3 times 2. And g prime of 2 is negative 3, just read from the table. And so we get this garbage for b. And the decimal approximation for this appears to be that stuff. Look, their work is exactly the same as mine. Negative 5.915. All right, part C. Write an equation for the tangent line to the graph of the inverse function of g at x equals negative 2. Yeah, that's a little janky. All right. So, what we're trying to find is so g of negative 2, or sorry, g to the negative 1 of negative 2 is what we're trying to figure out here, because that would be the value. So that the input into the inverse is the output of our original. So we're looking in our question for where g is negative 2. We want g of what equals negative 2. And so if I zoom up, it's g of 3, because that's the point at which my value of g is negative 2. My output is negative 2 of g. So I'm looking for that input, which is 3. And so 3 comma negative 2 is our point there. And now I'm all turned around because they use x equals negative 2. Why are they making me so sad? No, it looks like I did it right anyways. Man, that is some convoluted stuff there. All right. Weird wording for them. So, we know 3, negative 2 is a is the set of points we're going to use for this. Our x point is negative 2. Our y point is 3 for the function. I need my slope of my inverse. So I got to look at my slope at that point at x equals at x equals 3, which is when g is negative 2, and that's negative 4. And I can build my equation here, which is negative 4 is my slope. We're going to have an x minus 3 and a y plus 2. And that should be the equation of our inverse function there. Doink, doink. Oh, crud muffins. Mr. Kennedy, why did you do this wrong? Because you hate everything. So I did the first part right, but I found the slope wrong because I'm a absolute joke. Oh my gosh. I feel bad now. So you know that slope that I said was negative 4? Yeah, I forgot something really important about that. That negative 4 is not the slope of my inverse function. The slope of my inverse function is the 1 over f prime thing. So, and I wish I did not have to warp back and forth on the page. I'm sorry for the convolutedness of this. So, what I want is g prime of x equals 1 over f prime of g of x. it's this horrible equation. -4 was my f prime, but my slope is -1/4 because I need to plug it into this equation for inverse functions. And so that's actually my slope. And now I can build my equation with a -1/4 slope. And what, y minus 3 equals -1/4 times x minus x plus 2. Like meow. And inverse function acquired. That is a pretty brutal question. I can understand missing points on that one. And there it is there. How many points did they put for that one? 2 points. Whew. All right. D looks like it's implicit differentiation. That's something I got. Oh yeah, we got this beautiful question here. So let's just take the derivative of this thing implicitly. We get 2 times f, and I'm losing people. This feels bad. Wait, so how did you get g of -2? Okay, let me go back to that question. Wait, cancel. Please don't cancel. All right. Looking back up top, that original part where they say x equals -2, I need to look up here at the graph and figure out where the output is -2, which is at 3. And then I use that slope, -4, in the f, what is it, f to the -1 of x, or g to the -1 of x? Whoops. Like this sort of thing, g to the -1 prime. The slope of the inverse function is equal to 1 over the slope of the original function at that point. So g prime of that x value, which is 1 over -4. And that's the slope you needed to use, and then you just use x and y, -2 and 3. 3 for x, -2 for y. And you built your equation like that. So it was, whoops, I swapped those, y and x. Like that. And yeah, you're right. The problem is it needs to be for the inverse. So it's, say this question was, I'm not sure who wrote this. I think AP wrote this, but they should have said, because the input and the output have swapped y's and x's, and so when g is at x equals 2 is what they should have said. So that's what made this question so confusing, was they didn't provide enough explanation in the wording. That's why I freaked out when I saw it. If we look back at the question, it says at x equals -2, but we end up evaluating the whole question at x equals 3 because we're looking for the input to the inverse of g being -2. And so the question is poorly worded, and that's what made me run in circles constantly on this question. And if you ran in circles, that's reasonable because it was not well worded. Because x equals 3, actually, for the entirety of this question. So, yeah. That's crud muffins. Last one here. Implicit differentiation. If we take the derivative, we get this. And I kind of skipped a bunch of stuff there, but there was a little bit of chain rule here. There was a little bit of product rule here. And we get this big piece here. Now, we just have to evaluate a ton of these points. We're trying to find the value of dy dx at 3, 1. So we just say 2 times f of 3, which they gave us in the problem. F prime of 3, which we can figure out from the f prime that we found in part A, plus g prime of 3, which we can read from the table, equals 1 plus 3 dy dx. And this is, there's only one unknown here. Once you plug all this crap in, and it's a lot of calculator work, all you're left with is one value to solve for. And And the value you should get for this is negative 3.52. Or negative 0.352. Yikes. I can't say words. Feels bad. So once again, getting like a 4 on these is a really good score for right now. We're trying to get to the point where you can consistently get 6s and 7s on these. That's about the 5 range. You don't need to be getting full 9 out of 9s on every question in order to be getting a 5. You just need to get most of these parts. And honestly, this one had, and notice they bailed at the same step I did even, and just said calculator work. That was the remainder part of that question. Okay. Come on. Our last question was another one with a table. In fact, this one is startlingly similar. So for the sake of not losing too many numbers, because I'm down to only 20 people, I'm not going to go through this whole question, but this question startlingly similar. I'd be happy to post the solutions to this one if people want to look at that. I'm not sure what they give you access to looking at these. Was anybody able to see these scoring guides? Because I let people check their work, but maybe you can't see this. I could probably send this to those people who finished or grade them. Only the real fans are left. Ugh, that feels bad. All right. So real fans. Sorry. I haven't assigned any. Oh, you can see it, Daikun. Oh, that's fantastic. If you can see these, that is what I want to hear. And so process-wise, question 3, super duper similar to question 2 here. So it's 2 of the same type, and hopefully the kind of questions that were fairly brutal. You can't access the AP set website. Michael, do you have an issue logging in? Oh, no, Daikun says. Okay. Sorry. Then I will try to post that somewhere where people can see it. Where? Trying to think. Okay, these are ones that are released, so I can post these ethically. Trying to think of how I can post this to you. I'll make a link on my webpage for it. Okay, so last piece for today is I really need the 20 people left to give me some sort of indication as to whether or not the AP online things were actually helpful, these questions, or whether or not we should just be assigning kind of random questions and going over those like just normal AP questions. Whenever I sign it says it's unable to handle the request. Daikun thinks it's helpful for the online one. You like these ones? Wait, Chelsea, are you talking about the ones from the homework or the ones from the ones that I assigned here? And honestly, Sanjana, the questions on the tests are going to be hard, kind of like these, because they are open book and everything. So there's a CV that says all APs are posted until August. Oh. This one took so long to upload, but the problems were good. I like the online. Huh. Okay. If I'm ever able to get on the website, I'm sure they'll be helpful. Yeah, so I guess one thing I'll do now is, if you're like Michael and you can't really get on, are they going to slam short answer FRQs at us? Short answer. If you mean like these questions, yes. If you mean not like these questions, no. They're not going to make you like write an essay or something. Like they're going to like show your work on the steps and that sort of thing. Oh, a bunch of like quick FRQs? Maybe. My guess is they're just going to give you 3 pretty long free response questions with like these, with multiple parts that are pretty involved and require to use Desmos and all that sort of junk. So I would expect that. Maybe they will give you some shorter ones. Yeah. In 45 minutes, FRQs are designed to take 15 minutes. So they have 4 parts. So they could put or they have 3 to 5 parts is the better way of putting it. So they could put between 9 and 15 pretty meaty at bats on there, which is my guess of what they're going to do. Yeah. So back to the mean value theorem. Do we have to write a paragraph? No. Literally, go to your graph. Ideally, because it's in Desmos, you have your graph there. And just be like, yo, in my graph, the thing never went up to 6.5 up here on the interval. So it can't possibly have an average slope of 6.5 because its slope was never 6.5. And that would be good enough. Because you've talked about the average slope, you've talked about the derivative, and you said they need to match on the interval for the mean value theorem to be satisfied. So it's impossible. And that would be a good enough answer. So no, write a paragraph? No. In fact, you can write this all in math notes. F prime of x is never equal to 6.5. So average rate of change can't be 6.5 on 1 to 4. Meow. And that would be good enough. So, very few words, 1 sentence. What if we found the average value and showed it wasn't 6.5? If I don't remember how the question's phrased. It kind of depends on that. Let's go back to the question, please. And Michael, I can try giving you maybe a different class code, and maybe that would help you. If I give you one of my other classes' class codes, maybe you could log in there where you've struggled to log in elsewhere. I wonder if that would fix your issue. I was thinking about that in the background. Okay. Oh yeah, you could just find the mean value theorem across that interval. Do they give you f ever in the question? No, see that's the problem, is they never give you f. So you could, I guess you could find it by integrating because you have the tools. But finding f of 1 and f of 4 is so much extra work. So yes, you could absolutely do that, Chelsea. But I would not do that if you have a time constraint. I would try to know the faster way. But yes, that would work. You can actually integrate this on a calculator. So yeah, seems legit. It's not a class issue, I just can't even log in. So Michael, you should be able to make just a dummy account, I think. And then I can give you a class code, and if you try to log in on a different account, you could test whether or not your computer's the question. I think that works. Because it might be your account's borked, or it might be your computer has some sort of issue, like a pop-up blocker or a antivirus thing or something that keeps it from actually being able to load the website. Anyways, it sounds like I'll be giving you more of these. I'll look through. I wanted to see what your take was on these questions, and it seems like overall it's hard, but people have relatively positive opinions, so I will be posting probably 3 more of these in half an hour, so when I go through some questions. Do you think we will be going back to school? No, I don't. But we might end of June or something. Are you going to assign more today? Yes, probably in half an hour. I wanted to get your feedback before I assigned anything. So I had not assigned anything yet. And as per usual, you can always use the Barron's book. You can always do this, go to AP Calculus Here's the AP Calculus free response. Wow. And you can look up questions. If you just type in AP Calculus free response, you get a big list of all the answers, all the scoring guidelines, you can like do an entire free response test, grade it all, and see how you did as practice just on your own. So you don't need to do my practice if you don't want to, and you can always do things like that. And the kids who did that really showed a lot of improvement last year, and on a test this year where everything's free response, it's got to be one of the best plays. Here's 2014, just slamming these out. Bam, 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 bam. And we've done some of these questions already in almost all of these because I've stolen a ton from here. Like, hey, we did this one last week. But you still can get really good practice. Are you going to go through all the files uploaded for this set? Are you going to go through all the files uploaded this set? Huh. Oh, to grade. Oh. Huh. I can. Yeah, there aren't that many, so yeah. I mean, if it was 80 of you doing it, I would feel pretty bad about doing it because it's kind of it's like equally as much of a pain in the butt, but times 80 for me to do it as like graded as uploaded or whatever. But it's not bad when only like 7 people are turning it in per class. So yeah, right, Sanjana. I figured a fair amount of people did what you did. So yeah, I can give feedback to the people who left it there if they want it. I emailed pictures to myself. Is email blocked on the exam? On your computer, yes. On anything else, no. So, yeah. So yes, I'll grade the ones that are there. I can't promise when, but we'll see. How do we upload the work? If it's PDF, or what else do they accept? PDF, JPEG, GIF, PNG, text, Word, Excel, PowerPoint, all of those. So you just click on these boxes, and oh gosh, do I have any memory open on my computer? You should be able to upload there. They say you'll be able to do it on mobile. That's insane. I assume it's all going to be built in. You're not going to be uploading stuff on the actual AP exam. You're just going to be like working on the Desmos in there, and they'll just say leave the graph in the Desmos, leave your work in the Desmos, and you can just say, for part A, I use this part of Desmos, so that sort of thing. So, yeah. We'll see what they tell us on Friday. And so, yeah, my plan here, I'm going to give you 3 more questions. They should be a little bit of brain testers like these guys. I'm going to grade the free responses that people submitted, assuming they're finished, which is all of like 15, 20 people right now. Maybe a little more after this. And then I'm going to be posting homeworks in a 0% category that I'm going to make new so that parents can know that you are or are not working on things since break started here. Break, whatever this is called. So that's my general plan. Some of that will happen today, some of that will happen tomorrow. We'll see. But anyways, have a nice day. I feel like I'm getting rambly, and these streams go long when we're doing FRQs. These are heavy. I think the AP website is April Fool's for ranking me. Probably. Try Internet Explorer. Just kidding. Never do that.